Huh? Oh, it's not plugged in here.
Did you see me acting this?
Yes. There we go. Now, we'll start now. Guys, we'll start. So, who am I missing now? Ray. David, come on. Mo. All three of them, huh? All three of them. But I just write down 3 Ukrainians. Who's Ukraine? Mo, Ray. Oh no! Wait, we have 2 of them. Mo, where's Mo? Oh, there you are. All right. Right, we're just missing 1 Ukrainian now. And here he is. Okay, so we're back down to just missing Ray. Who else now?
Joshua.
Am I missing anyone else? Hey, come on. Okay. All right, so we'll get started now. Last time we were looking at averages, so now we're having a look at standard deviations. So average is a statistic which can... So, what's wrong? Oh, come on. Right, so as I was saying, average... I'm trying to start now, come on. Okay, so average was a statistic to summarize the data. It sort of gives us a middle point nearly, right? It's sort of a center. But we actually discovered there's actually many types of averages, and I taught you 4 of them in class. Okay, so we had mean, median, mode, and midpoint. Okay, but I mean, there's other ways you can calculate an average as well. Now, there is some problems with averages, but here's an example of one big problem with average. So suppose I have data A, which we'll keep it simple. We'll say it's -1, 0, and 1. If you get the mean average here, what is that? Well, you can calculate, it'll work out to be 0. The median average? 0. Mode average? No mode average. And the midpoint average? It'll be 0 here. If I look at data B, mean average? 0. Mode, none. Median, 0. Midpoint, 0. So all the averages are the same. But you would say the data is quite different, isn't it? Yeah. This data is much more spread out, than the first data. So we need a way to measure how spread out data is. So how wide it is, if that makes sense. Now, you might have a couple of ideas. You could say, well, what about if I use something called the range, which would be the maximum minus the minimum. So here, the range would be 1 minus minus 1, so that would be 2. And here, the range here would be 200. And the range isn't too bad, but there's problems with the range. For example, if you had data like this, let's say I had minus 100 minus 1, minus 1, minus 1, 0, 1, 1, 1, 100. Is this data more like A or is it more like B? Well, it's more like A. I would say it's more similar to A than it is to B. Because what's quite common in this data set? Minus 1 and 1. Yeah. And what's quite rare? Minus 100 and 100. But the range here would be 200. Even though most of the numbers are near 0, the range is still 200. So we don't use range. I mean, range is okay to use. There's nothing too bad with it. But we have something else that we use called the standard deviation. And it's a way to measure how spread out the data is. And I'll give you the formula now. You probably have seen the formula before. So standard deviation represented by sigma. What you do is you add up all the data's difference between each point and the mean average. You square as you add and you divide by how much you have. So I'll give you an example. We'll take the first example of minus 101. Standard deviation would be minus 1, the first data point, minus the mean average. What did I say the mean average was? Was 0. Squared. Plus the next point, 0 minus the average, squared. Plus the last point, 1 minus average, squared. And in this case, it's all over 3. And that's the calculation here for this one. Yeah.
Is it the same formula?
Oh, is this the same as this?
Yeah.
Oh yeah, I'm just using this here as an example. Add up the points minus the average squared all over the total number of points. It's most important that you know how to calculate it. So the difference between, the difference between the point and its average squared, add them all up and divide by how many points you have.
Okay, what about the rest? 0 minus 0 squared.
Well, that's 0. Yeah.
He's asking where do you get it?
Oh, I'm sorry. I left out something in my formula. Maybe someone has spotted it.
Yes.
No, in my definition here. Yeah, this is actually for square. I just left out the square. So there's one thing left to do. This is equal to, what fraction would this equal? You don't need a calculator, come on. 2 over 3. Yeah. So the standard deviation will be square root 2 over 3. What's that, like 0.8 or something?
Yeah, 0.816.
0.816. I'll do another example. Yes, you first.
No, the example.
Okay. This point minus the average. Yeah. I'll do another example. Yeah, can I scroll down?
Second. Yes.
Scroll down? Yeah. Okay. So we'll keep it not too difficult again. We'll have 5 data points here. We'll keep it simple. We'll have 1, 2, 3, 4, and 5. And we can easily get the average here quite quickly, perhaps even in our head. What's the average here? Who can spot what it is? It's going to be 3. Okay? So the standard deviation squared is equal to 1 minus 3 squared plus 2 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared plus 5 minus 3 squared all over 5. That's equal to 4 plus 1 plus 0 plus 1 plus 4 all over 5, which is 2, right? So that means sigma is square root of 2, which is 1.4141. So the standard deviation is 1.4. Yeah?
If the average was 2 numbers, we add them until
No, we're taking the mean average. So the way I got the 3 was 1 plus 2 plus 3 plus 4 plus 5
Divide
over 5. Yeah.
So this is the average.
Yeah. Yeah. From last class, remember?
Yeah. But they didn't get like the formula.
Which formula?
That one.
Yeah, but can you see how I'm using the formula?
No.
No! 1 minus 3 squared, 2 minus 3 squared, 3 minus 3 squared, 4 minus 3 squared, 5 minus 3 squared, all over 1, 2, 3, 4, 5.
So like every
Yes,
value
yes,
minus the
yes,
average.
yes. Squared,
Yeah, then divide by
add them up and divide by 5, yes. Yes? Alright,
What's second, please?
So for this, do we have to give a final answer? We can leave it as the exact answer.
actually, because the statistics question, it'd be more normal to not give the exact answer and to give the decimal answer for statistics. Yeah, you got that?
Yeah.
Yeah. Yeah. Now, the sigma here is called standard deviation. And does anyone know what sigma squared is called? It actually has a name. It's called the variance, yeah. And this is the standard deviation. We won't be concerned about variance just yet. I just care about standard deviation for the moment. Yeah. Not video assistant, referee, no. Okay, can I scroll down?
just a second.
Yeah.
Just
Yeah.
Variation, right?
Variance.
Oh, variation.
Okay. Yeah, scroll down.
yeah.
Yeah. Now, what exactly does the standard deviation represent? So there is a good approximation to the standard deviation, and it gives us a good picture of what the standard deviation represents. So let's go back to our example of our 5 points. 1, 2, 3, 4, 5. I'll just put them in a bubble here. So we imagine this is our data. What is the mean average here? 3. Okay. So our 5 points are 1, 2, I'll just put 3 here, 4 and 5 like that. Okay. So how far away is 1 from the average? It's 2 units away. Okay. How far away is 2 from the average? 1. How far away is 3 from the average? 0. And then here, 1 and lastly 2. Okay. Now, on average, how far away is each point from the average? Well, the first one is 2 away, then 1, then 0, then 1, 2. So we'll add them up. 1, 2, 3, 6 over 5, which is 1.2. Isn't it 6? 2 plus 1 plus 0 plus 1 plus 2? 6. Yeah, isn't it? 6 over 5. 1.2. There's 5 numbers, isn't there? Yeah. So, on average, how far away is each point from the average? 1.2. Now, this isn't very different to our previous answer of 1.4. No, it's not exactly the same. But this is actually a good guideline to what this number represents. This is like the average distance each point is from the center. Okay? So, for example, if I had this class's height, and I got the average height here, and I'd say that's, whatever it is 1.65, or whatever it is everybody going to be 1.65? No. Some people are going to be over, and some people are going to be under. Okay? The standard deviation tells me, on average, how far away each person is from the average height. Okay, it's like an average distance from the center. Yeah. what if the standard deviation was 0? What would that tell me about the data? Everyone's the same and everyone's the average. And what if the standard deviation was very large?
The difference is like.
The difference everyone is from the center is quite large.
Yes.
Okay? So, the next thing I want to show you is there's a second way to calculate standard deviation. You might find it easier, but it gives the exact same answer. Can I scroll down? Yeah. Now, just before I do, oh yeah, so just to say here, if the n was bigger, then this approximation would actually be closer to this value. Okay? So if you had like 1,000 people, then I think the difference would be tiny. It'd be 1.4 and 1.41, something like this. Okay? So even with only 5, it's a decent approximation. Now, before I give you the next formula, I just need to give you a little bit of notation here. So this symbol here, this means you get the mean, then square. Whereas this here, you could probably guess what this means. It means first square, then get mean. Using this, we have this very nice, neat little formula for standard deviation. We can say standard deviation squared is equal to this minus this. I'll give you an example of how this works now.
This is like a new formula?
It's a new formula, but believe it or not, it gives the exact same answer, and you can show it's the same. Yeah?
Can't you just make it like standard deviation equals to the square root of this?
Yeah, of course, yeah. Yeah. You want to write it like this, is it, David?
Yeah.
That's fine, yeah.
Is it like exact same number?
Exact same. I used to do the proof, but I won't bother you with the proof. I can prove to you that the other formula and this formula are the same. Exactly the same. Okay. Can I look at example? So what I'm going to do is I'm going to use the same 5 numbers, but use this formula now. Okay, so using the same 5 numbers. 1, 2, 3, 4, 5. Okay. So first thing, this symbol here means you get the average and then you square. So what did we say the average here was? 3 and square? 9. Right?
Yeah.
Now this one here says first you square and then get the average. So that becomes 1, 4, 9, 16, 25. And let's get the average here. 25, 30, 55 is it? 11 is it? 11. See what I've done? I've squared the data, then I got the average. Here I get the average, then I square. Here I squared, then I got the average. So the order does matter. You get 2 different numbers. By the way, the second one here will always be bigger than the first. Okay, so according to the formula, what does sigma squared equal? 11 minus 9, which is 2. So sigma will equal, well, look at that, exactly the same. Yes.
Wait.
Can you
Repeat what?
the 9 and 11 how to do it?
You tell me. You know how to.
The 9 is the average
Yeah.
square.
Yes, correct. And the
the
11?
The 11 is like you square all the numbers.
Yes.
You add them together. Then
You get the
divide.
average.
Yeah.
Yeah.
5 or what?
5.
Yeah.
Yeah. Like you get the average.
Yeah, listen to Hazel. Good job. Right. Do make sure, yeah. Okay,
Voilà.
we're writing it down. What's wrong?
That's it. Okay. So,
Okay, you got that? Yeah. So, by giving the average and the standard deviation, you can get a good picture of the data. I'll give you an example. Scrolling down. Suppose I give you some data. Suppose I say oh, by the way, sometimes the letter S is used for standard deviation. So, let's say the average is 110 centimeters. And we'll say the standard deviation is 5 centimeters. So, I know that my data is mostly going to be near 110 centimeters. Right? Of course, there will be some which will be more and some which will be less. But I also know that mostly they'll be about 5 centimeters away. Some of them will be less than 5 and some of them will be more than 5. So, like, I could make up an example. Maybe, you know, in my mind I'm picturing something like on the right I could have 115, that's 5 away. 110, that's 0 away. And 120, that's 10 away. So, how far away is 115? 5. How far away is 110? 0 and 120? 5, yeah. So, I mean, roughly, you know. And I could do the same on the other side. So, I could have then 5 under, 105. I could have another 110 maybe. And I could have a 10 away, 100. Now, I'm not saying that this is the data. I'm just saying this is, you know, I imagine that the data might look something like this. Okay. One useful thing about standard deviation is, for most data, most of the time, you'll always be no more than 2 standard deviations away. So I can quite confidently say most of the time, I'll have the average plus or minus 2 standard deviations. So I can really say here that most of my data will fall between 100 and 120 centimeters.
what does standard deviation mean? The 2.
Well, which one?
The 2 is. Yeah.
Oh, this is like empirical rule. 2 times it. Twice the standard deviation, yeah. If you look at the data, you will see that most of the time, most data will always be within 2 standard deviations of the center. Now, the reason for this is kind of complicated, but it's to do with the data being what's called a bell curve. This is when most of the data is in the center, and then you have less data as you move out. When you have a picture like that, then this is usually true. So the next time you have some data, you can see this for yourself, that most of the time, all the data points will be within 2 standard deviations of the center. Okay. Now, it's not all of it. In real life, it's more like 98%. Okay. So, using this and this, I have a good guess at what the maximum is. I think the maximum will be 120. And I can have a good guess at what the minimum is. I think the minimum will be 100. Yeah?
Yeah, okay.
Okay. Now,
But how
yeah.
the minimum will be 100 and it's like, it's 105.
Oh, I only have 6 numbers here. If I have maybe 100 numbers, I expect some of them to be around about 100. Yeah. Now this, this is just me making up some numbers here in my imagination. Like if somebody says to me the average is 110 and the standard deviation is 5, and I need to imagine up what the data looks like. I imagine something like this. You know, I'm not imagining numbers like 200, am I? Why is 200 obviously wrong? It's way too big, isn't it? It's way too big. Because remember, the average has to be 110, and you need to be about 5 units away. Well, how far away is 200? It's like it's 90 units away. And the standard deviation is 5. So you're 18 standard deviations away. It's too big. Yeah? Yeah?
How can I know, like how many terms?
Oh, this is just an example. Just in my mind.
No, I'm asking in general. How can I know how many
You
terms?
can't. If I tell you the mean and the standard deviation, there's not enough information to know how many there was. So typically when you read research papers and they say, oh, we measured patients' blood sugar levels, okay? The 3 statistics that they always give you as a minimum is the average blood sugar level, the standard deviation of the blood sugar level, and the number of participants, which would be n then. Okay, these are like the basic 3. Yeah? No matter what research you're doing, you have to at least give the reader these 3 pieces of information as a minimum. Average, standard deviation, and sample size. Yeah? Because the sample size would let the reader judge if you took enough cases or not. Yeah? I don't know if Colin has talked to you about this, but what is considered a minimum good sample size? A minimum. Has Colin talked to you about this? 20, is it? 1,000. That would be impressive for medical research. I don't think they usually get these many people for clinical trials, do they?
It's like LSD testing or something.
Oh, it would be good, but what would be a good minimum? Yeah, I think for me, 30. Might get away with 25, and exceptionally maybe 20, but really 30. Anything less than 20, you're just wasting everyone's time. It's worthless result. 30 is what I would say the minimum standard. Okay, so did you write that down?
No.
Quick, come on.
We need the example.
Example of what?
Like, it's the same thing.
Another example, okay. What things have you measured recently in chemistry or biology? You did the labs, didn't you?
Yeah.
So is there something that you measured recently?
And
And yeah, so did you have to get an average?
Yeah.
Yeah, so what was the
Yes.
average for that?
Wait, I have
Well, tell me firstly, what's the unit for enzyme activity?
There is no unit.
What's the volume of
pH.
Okay, cm cubed. You're measuring a volume as a way to measure enzyme activity. Okay, so what you don't have to remember, like what scale is the average? How many cm cubed we're talking about?
50.
50?
Yeah.
Now, were all the values 50?
No.
No, so what would be the smallest value?
0.
0, 22, okay, and the largest value?
Like 58.
60.
So are you sure the average is 50?
no 100 probably. Oh, no. We need to check.
Ah, okay, great.
Just zoom out.
Yeah, you didn't send it.
Or are these everyone's group, is it?
Oh, nice. Great, very
This
like.
one.
Please take our phone.
It's okay, it's full of memes. Nothing special.
So I see that there's, like, on the first one, there's 4 results in 20s, is it? And then there's another 20, 17, 50, 44. Yeah, actually, so I don't think the average will be as high as 50, because 58 was the highest number I can see. So maybe the average was more like 30, something like this, 25, 30. And the standard deviation, I would say, is 10, roughly. Because when I say this, what I'm saying is most data will be between 10, and 50. Was that true? No?
Oh, maybe you're
I think
looking at the pH.
pH doesn't usually go to 50, does it?
Yeah, I mean like the temperature in the fan.
Anyways, it no matter. The point I'm making is that when you look at the data, guys, the point I'm just making here is when you look at the data, you can kind of get a rough instinct for. Now, hang on. I will kick you out. Oh, no. I will. Okay? I will. Trust me. Now, as I was saying, my only point I'm making here in this example is when you look at the data, you can get a rough feel for what the average and the standard deviation is. And that's an important skill, especially the opposite. When somebody gives you the average and the standard deviation, you just have to have a rough picture in your mind of what type of numbers they're talking about. Okay? So you need to have a little bit of an intuition here when you're reading some research paper. You know, if somebody said, oh, the blood sugar level was this and the standard deviation is this, you need to have at least a rough idea of what type of numbers they're talking about was in their data. Okay, so would 700 be a good value here? No. It's way too big. Okay, 35? Yeah. Okay, so that's what I mean, just an intuition, that's all. Okay, so for a few minutes, you can get started on some homework questions here. I think, nah. Well, if you want to, go ahead. But these are quite straightforward, so really 1 to 4 is enough.
Teacher,
Yes.
here you said like the standard deviation, like
Yeah.
if it's 2, it's like it's gonna be 20.
If it's what?
It's 2.
It's going to be 20.
Yeah.
I don't think I ever said that.
You said like you multiply by something, but it's power.
What? I think you totally misheard me.
Okay, so now like this sign like means the average
Yeah.
of the
Yeah.
so it's so the
Yeah.
standard deviation means if it should be like more or less.
Could be anything. It could even be 100.
Okay.
Yeah, it could be any number. Both could be any number.